every major catastrophe seems to provide opportunities for new biological forms. So it was with the Ordovician Silurian extinction. Heretofore, life was bound to the seas, an environment that strongly attenuates light and limits the diffusion of carbon dioxide. A mild climate following the extinction, and plants emerged from the aquatic habit about 430 million years ago and colonized land. The ascent to land was a formidable undertaking. In their ancestral aquatic habitat, all cells are bathed by or in close proximity to water and the nutrients dissolved in it. The restlessness of the surrounding fluid promoted mixing as well as diminished the boundary layer between organisms and their medium, and so their absorption of water and nutrients did not result in local depletion of these substances. Encroaching on land, plants left behind this relatively benign habitat. On land, a desiccating atmosphere sucked water from organisms. Water and mineral nutrients were available primarily on the surface of or embedded in particles of soil. Soil was a stubborn medium, one that was often difficult to penetrate and that suffered from limited mixing and local depletion of water and nutrients. Plants in a terrestrial environment, however, gain greater access to the critical resources of light and carbon dioxide. In bodies of water, light for photosynthesis halves every 0.2 to 5 meters in depth, depending on turbidity of the surface and the density of photosynthetic organisms. Diffusion of carbon dioxide is roughly 10,000 times slower through still water than through air. On land, freed from these limitations, the productivity of plants literally skyrocketed. Vast jungles covered the continents. These jungles, however, were only millimeters tall. In primitive plants such as liverworts, water and nutrients transport from the soil to area parts and flow of carbohydrates from photosynthesis to the light-deprived below-ground parts depend on inefficient cell-to-cell mechanisms. Slow movement of materials thus restricted the height of such plants to a few millimeters. With the advent of a vascular system, essentially the invention of indoor plumbing for plants, about 380 million years ago, plants were able to extend their reach. Vascular plants have specialized tissues that serve as efficient pipes through which water and nutrients flow rapidly for meters and beyond. Once these transportation problems were addressed, plants grew in stature. Towering forests of vascular plants dominated the Carboniferous period, 360 to 290 million years ago, so named because the organic matter from these forests eventually became the coal deposits that powered our industrial age. The appearance of more complex plant life enhanced the amount of photosynthesis worldwide. Atmospheric concentrations of oxygen rose from 15% to 30%, while those of carbon dioxide declined from 0.5 to less than 0.05%. Lower concentrations of this important greenhouse gas were associated with falling global temperatures. The Great Dying at 250 million years ago, the most severe extinction event in the history of the planet, marks the end of an era, the Paleozoic. Over 96% of marine and 70% of terrestrial species disappeared. Possible causes include an impact event in which a large meteor struck Earth, major volcanic eruptions, or methane release. Because no single cause for this devastation is evident, the convergence of several factors is suspected. In one scenario, massive volcanic eruptions released vast amounts of carbon dioxide to the atmosphere, initiating global warming. This warming diminished the temperature gradient between the equator and the poles, which in turn disrupted circulation of the oceans surrounding the supercontinent Pangaea. The stagnant waters heated sufficiently to melt methane hydrate, ice that contains large amounts of methane within its crystal structure in deep seabeds, and produced a massive release of methane to the atmosphere. Global temperatures soared. Oxygen availability in the warm, stagnant oceans surrounding Pangaea dropped, and sea life suffocated.